Recording's on. Welcome everyone. So there was some feedback on the videos of 2 weeks ago, and I fixed the keyboard for the recording, and I fixed the fact that you can hear people. Let me check again. Yeah, so that should be good. And instead of having one large video chunk session, we're gonna split them into 4 separate smaller sessions of 10 to 30 minutes, depending on how smooth things go. So let's get started. So last week, we're going to continue from the branch that we made last week. Last week we did the create default build beams. And this week we're going to look at the UEF build slice beams. And the slice beams are these ones. This is the slice beam right here. And just like we did last week, we're just going to copy this entire function, put it in a separate file. Hold on, I'm not streaming. Yeah,
You're not streaming.
Yeah, all right. I just started recording, but I didn't start streaming. That is brilliant. All right, let me restart that. All right. Okay.
Task was not achieved this day.
Yeah.
Great hearing your voice, but I'd like to see what's going on.
All right. I do think my laptop is gonna die at some point. So if the stream is really horrible, I'm like, my laptop at the moment is 10 FPS. Okay, so that was a good start. Let's just continue where we left off. So this is the build beam that we're looking at right now. And just like last time, we're just going to grab the entire function. And we're going to copy it to the file we were already working in about the UEF effect utilities. And again, just like last time, we immediately create the reference. The very bottom is import all of this. Is the stream alright? For those in the Discord?
Looks perfect on my end.
Alright.
Also, hello Sparrow.
Perfect, works for me.
Hello Dragon.
Alright, there we go. Good start. We broke it. Access to non-existent global variable. I just fixed that. Did I make it local? No. I need to save this file. Right. Alright. Let's check again. Nope. UEF, create UEF build slice beams. Commander build slice beams. I copied the wrong one. Yeah, I copied the wrong one. That's a good start. And try again. That's odd. The right one's here. Alright. Attempt number 2. So we imported back into the file. And in contradiction to what we did last week, where we just started hacking away right away, this time we're just going to do a bit of an analysis up ahead. And since the changes that we're going to make primarily involves the garbage collector and not so much the simulation speed itself, we're going to take a different approach to analyzing this. So let's first make sure that our changes are gonna get recorded by adding a tiny log at the top. As usual, again, the engineer class is changed, but all the instances are not. Not all of my units. Nope. There we go. Which means that we gotta respawn the engineer. So let's do that. Let's clear the logs. And there we go. So the changes that we're going to apply to this file are going to get recorded right now. Now, it's a bit difficult to see the actual impact, so to help us with that, we're going to list the bytecode of this function. And we're going to see that once we're done, the bytecode of the function is going to be significantly shorter. Now, what does the bytecode of a function actually mean? This is the bytecode of the function that we're going to optimize. So let's just copy this in. And bytecode, you could see that as the intermediate code that is actually being processed by the processor. It's not entirely correct in terms of Lua, because this code is processed by C and that code is processed by the computer. But this is not far off from, for example, assembly. And we're going to use that.
Very close.
Say again?
I said it's very close.
It's very close, yes. And we're going to use that to get an idea of what is really happening in the function. And we're going to use it to compare with ourselves once we're done. But in particular, we got to make the note that this is not the entire bytecode that we're seeing. Because, for example, we have function calls here at line 100, which you can see if we go to line 100. We've got this call right here, which is the function call. And that means that the bytecode of this function is being run too. So let's add that in. There we go. This is another Lua function. So we can add that one in. Wait seconds is another Lua function. So we can add that in. So let's do that. Let's add a log statement to make it easier to read for ourselves. And last one. Wait seconds. Now you may wonder, why are we not adding in the vector function here, or the set velocity function, or the get fraction complete, or the warp? And the reason for that is that list code only works on Lua functions, because it can only determine the bytecode of Lua functions. Whereas warp, get fraction complete, vector, these are C functions, which means that they are implemented in C on the engine, and we just have a reference to that function so that we can make a call to it so that it does things for us. That's why all the other functions that we're seeing here are not added. So let's look at what we have. If we print this out, did I do it right? I did not. Let's try again. And then we gotta kill the engineer again. Oh,
First viewing something.
I think I made an error. Let me check that right away. Wait seconds. This should be util dot, because it's util dot here too. All right, so that crashes the game. Let me kill that.
In peace game.
Yeah. Oh, it's back. It's back. That almost crashed the game. Correct me. So let's, there we go. Copy that out. Alright, so this is what we're really working with right now. We've got the create UEF build slice beam itself. That's the larger chunk of the bytecode that we have. Then we've got this get closest vector function, and then we've got this wait seconds function. And all of that combined is the bytecode that we're dealing with. And I hope that at the end of this session we can do a comparison side by side and see that the one on the right is significantly smaller in comparison to the one on the left. But let's not get ahead of ourselves. Let's first look at what we have right now. The game is stuttering a bit. So what are we actually doing here? There's two parts of the function. One is the setup of the effect, which is all of this, and then there's the while loop here that continuously switches the direction of the beam. So what we're doing in this first part is if we have a factory and we look at it from the top like that, then we have a new, there we go, then the first part essentially determines, does that work? No, my tool doesn't want to work. Oh, there we go. The first part, here we go, essentially determines the 2 points that we want to move between, which is this point here and that point right there. And once we're complete, it's that point there at the bottom right there. And continuously the beam moves like this and that between those points. So the first part of our setup here primarily involves into creating those points. There's a projectile here, that's the projectile that's actually moving on the other side of the beam. So we've got the engineer on this end, then we've got a beam between 2 entities, and we've got the projectile on the other end. This projectile is actually interesting because if we look at what the projectile really is, by all means, this is a dummy projectile, right? It's not going to collide with a shield, it's not going to collide with units, it doesn't do damage. We purely use it because it allows us to move from left to right in interpolated fashion. But if we look at the projectile and its definition, so let's grab that real quick. As said during the last session, the repository is not entirely complete. Not all the files from the base game are in the repository. This is one of those files that is still part of the base game. All of that is because of licensing issues. But if we look at the original file, we can find that here. There we have it. Then if we look at the inheritance class, the UEF build projectile, which doesn't do anything, right? It just has some emitter trails, inherits from emitter projectile. And if we look at emitter projectile, which is right here, that inherits from projectile. And if we look at projectile, which is right here, then we have this gigantic class with all its functionality. And in particular, we have this onCreate function right here that is being run, which means that the bytecode that we currently have is actually incomplete, because in this line right here, we're not just creating a projectile, we're also running all of this onCreate code and all of this onCreate code right here. So that's actually a pretty expensive line right there, and we're going to come back to that later. But for now, we're creating a projectile. We're attaching the beam that we're seeing. So the beam is this beam right here. We're attaching a emitter, this blue glow, to the builder. That's the blue glow that we're seeing right there, right? The tiny blue glow. The other blue glow on the other end is part of the projectile. So if we go back to the projectile, we can see here the Terran glow and the sparks blue. So that is the effect that we're seeing. Then we're off to determining those 2 points we mentioned. So given an engineer, typically it uses the closest 2 points. So if our engineer would be on this end, and we would tell it to help again, it will go between these 2 points. Same thing here, these 2 points, and etc. The 2 closest points here. And one could argue that if you have a screenshot from above, let's put you on pause again. Let me open up my tool here. There we go. That if we would make a drawing of the situation, this would be our factory right here. And then here we have a bunch of candidate points, which are these corners, right? And one can argue that if the engineer is in this part right here, in this top part, let me enhance, where is my, there it is, then the two closest points, or the points it will use, would be these top two, right? Because those are the two closest points, right? And if we are in this section right here between, so in this quadrant that we have here, then the two closest points would be these two, and in this quadrant it would be the bottom two, and etc. for the left one. This is something that we could use later on when we're optimizing, because what we're doing right now is we're making a list of all the points. We go over all the points and find the closest one. We go over all the points and remove one by going over all the points, and then we go over all the points and then we unpack them, and that's how we get the 2 points, right? End fact 1 and end fact 2, which is a bit redundant, right? There's a lot of looping going on in here, because if we look at this closest get closest vector function, then inside that function we will again here find a lot of looping, a lot of additional function calls, and that function call is essentially a wrapper to an engine call, and engine calls are relatively expensive. So that's a lot of logic being run for determining the closest points, right? The 2 closest points given this square of your factory.
It's sexy.
Yes, that's one way to put it. And then we've got the initialization. So this puts the point in the center at the start of the build cube. If we help assisting this building right here, then it starts going left and right immediately. But if we start a new building, then it starts in the center at the bottom right there. And that is what we're seeing right here. That's this bit of logic here. And then we've got the loop itself. And throughout the loop, as long as the builder is not destroyed and the unit being built is not destroyed, then we essentially move into one direction with a given velocity. That velocity is the total distance. So we've got the distance between point 1 and point 2. So that's point 1 and point 2. We multiply that by 2, that becomes our velocity. So in half a second we'll move from the left side to the right side. That's why there's a wait seconds of 0.5 here. We just set the velocity of the projectile. This is why we wanted a projectile, right? Because you want this smooth interpolated movement. And after half a second we warp it back to the outer edge. So right there, because it could be that it got slightly overextended itself. So we warp it back into position, and then we flip the velocity, right? So this is essentially the same right here as it is right there. And that creates the actual animation, the movement. So there's no animation files, there's no 3ds Max or Blender animation going on here. This is just a projectile going back and forth. So that's roughly what we're looking at. And we've got the bytecode here already. And in the next part of this session, we're going to start actually optimizing this function. It's always important before you start doing these type of things that you understand what it is that you're doing. And in this example, we want to replicate the exact same effect. So in all instances, it should be the same effect. But we want it to be cheaper. So less instructions, less memory allocated. But before we do that, let's first take a small break and allow people to ask some questions. Right. So let's take a small 5-minute break.
One question I've always had, Chip,
Yeah.
is the various engineer builder functions. Is why do we decide to keep all these functions? Anyway, UEF one, as you said, has several.
You mean why there is a create default build beams and why there is?
I mean, not just that, but why do we need? And I think there's four. There's the factory one, the engineer one.
Oh, good question. So yeah, so because you mean that there is a, where are you? This is the commander version.
Yeah.
Right here, and this is the factory version, if I'm not mistaken.
Yeah.
Or is it this one? And then we've got the actual build cube itself. So that's another part of the animation, which is this thing right here, right? That's the build cube. I think the reason for that is pretty simple. The commander, for example, is different from the other animations in terms that you've got two beams going, you know, into each other constantly. And with the engineer, you've just got 1, 2, or 3 beams, but they all follow the same pattern. So that's why you've got a special one for the armored command unit. And in terms of the factory is just picking a random point, if I'm not mistaken. Yeah, which is again completely different from the build animation that we have right there. So in those terms, that's why we have many of these type of functions. Does that give you a bit of intuition?
Yes, and does it add anything to the memory to have multiples of these functions?
Well, no, not really. It just adds to the aesthetics of the game to make everything feel unique.
It does add to the table size of the class.
Yeah, that's
of
true.
The module.
Yeah, it does add another entry to the module. That's right. But given how tables are implemented, the chances that it collides with another function, that depends on the last 6 characters of a function. That should be relatively sane, unless it ends with red. Those always collide, and all of these collide too. For some, oh well. But yes, it does add another entry to the class. Alright, I'm gonna restart the recording.